laws of thermodynamics. Okay, there are three laws of thermodynamics. First one is named called as zeroth law of thermodynamics. Second one is first law of the thermodynamics. Then last is the second law of thermodynamics. Okay, if you have one doubt why it is called zeroth law means, actually they named the two laws, that is the first law, second law considerable already. Okay, so after that only this law will be considerable. So give the importance of this law is named as a list of one named zeroth law. Okay, so zeroth law of thermodynamics is the 2-mark question. A and B are the two systems. System means the pressure, volume, temperature will be various within A and B. Okay, so if A and B are in two systems or contact with the C in the another system. Okay, so what does the statement means? If the two systems A and B are in thermal equilibrium or linked with the third system C, okay, then A and B are in thermal equilibrium with each other. Okay, for example, system A has a hot, system B has cold. Okay, then how it is possible to make it both in temperature are equal? That's called thermal equilibrium. Since A and B are not in contact, okay, first what will happen means the hot object of the system A will transfer the heat to the C. Okay, after some time the temperature of A is equal to temperature of C, which means A and C are in thermal equilibrium because of the amount of heat energy transfer from A to C. Okay, then the temperature of C, then temperature of B are not same, because we know C is getting heat from the A, so C has a little bit hotter than the B, so it is transferred from C to B because B is cold, it's a lower temperature, it can acceptable the amount of heat energy. Okay, so that after some time the temperature of both C and B are same. Clear? So we can conclude that TA equal to TC, and final TC equal to TB. Then we can equate that both the T and TB. So TA is equal to TB. Okay. Consider three systems A, B and C which are in initially at different temperatures. Okay. So assume that A and B are not in thermal contact, okay, with each other, but C is in contact with both A and B. Okay. So after a time, okay, the third system gain the energy from A. So both are equal in thermal equilibrium. So TA equal to TC. Okay. Then after that, at a time, TC equal to TB. Okay. And finally, we can say that TA equal to TB, where TA, TB, TC are what? In temperature of the system A and B, C respectively. Okay. Next, where we use this law of temperature means, okay. So zeroth law of thermodynamics is able to determine the temperature. Okay. For example, when a thermometer is kept in contact with the human body, okay, it shows that what the actual temperature of the human body, no, by the increasing of the mercury in the thermometer, it shows the actual temperature of the human body at a time. Okay. So at this condition, the temperature of the thermometer will be same as that human body. So it is transferred within that human body to the thermometer. Okay. So this principle is used in the finding the body temperature. Okay. Used in finding the body temperature. Next we will see that internal energy. Okay. Its symbol is U. Okay. Internal means the energy you getting from the inside the body. Okay, or any material. Okay. So internal energy of the thermodynamic system is the sum of kinetic energy. So kinetic symbol is EK with the potential energy EP. Okay. So sum of the kinetic energy and potential energy of the molecules of the system. Okay, that is called internal energy. Okay. Now, how can you find out the kinetic energy of the particle means? Okay, the energy due to the molecular motion, that is including the translational. Include the translation means the molecules move in a straight line. Okay, translational and rotational, and then vibrational. So kinetic energy means which refers that motion of the molecules inside the body, that is the translation motion, move in a straight line. Rotation motion, move in a circular line. Vibration means moving in a horizontal or vertical. Okay, so this kind of motions occurs in the body of system is called kinetic energy. Okay, next, potential energy means the energy is due to the molecular interaction. Molecular interaction is called the internal potential energy, EP. Okay, molecular interaction. Okay, so internal energy formula U is equal to EK plus EP, which means kinetic energy plus potential energy. Okay, next, how can we treat as this internal energy in that any metal of the body? Okay, for example, know that the ideal gas and real gas we are studying last year 10th standard. Okay, ideal gas means the molecules of the body which do not interact with each other. Okay, this is called ideal gas. Real gas means the molecules of a body which interact. It may be collision or vibration, whatever, you know. So all things are possible within the molecules inside the body. The kind of the gas is called real gas. Okay, so here since the ideal gas molecules are assumed to be no interaction with each other, okay, so that the internal energy is only consists of the kinetic energy. There is no interaction. Okay, which depends on the temperature. Okay, temperature, then the number of particles in the gas molecules. Okay, and then and volume. Okay, depends upon the temperature and number of particles. Okay, and volume is not dependent because volume means it will be changing the size. Okay, so for ideal gas the internal energy will depends upon only on the temperature and number of particles, and independent of this the volume. Okay, but in case of the real gas, okay, which means this means the interaction between the two molecules in the same gas. Okay, it's like a Van der Waals equation. Van der Waals gases means the gases the molecules are always interact with each other. Okay, you can possess the internal energy. Okay, and then this is first topic, first application for the internal energy. Second thing is internal energy is a state variable. The state variable. Okay, which means it depends only on the two values. Okay, that is the initial and the final states. Okay, initial and final states of the body. Okay, for example, if the temperature of water, okay, take the beaker, then fill with the water. So we measure the temperature with the help of thermometer, say 30 degrees Celsius at initial. So put TA. T is called initial temperature. Okay, then it is raised by heating. By heating means the temperature of the water will be raised. Okay, become 40 degrees Celsius. This is the final temperature. Okay, how can you find out the internal energy of this water means? Okay, the difference in that two temperatures. Say U is equal to internal energy means U equal to the difference in the temperatures. So 40 degrees Celsius minus 30 degrees Celsius is equal to what? 10 degrees Celsius. That is the temperature rise by the water while heating. So the internal energy of the water getting the heat energy. Okay, what's the value? This is 10 degrees Celsius. Okay, so we can explain in the other way also. Third way, consider a hot object, consider a cold object. It's a very hot object, is a very cold object in temperatures. Okay, so both are contact with the thermal contact here. what will happen? For hot object it has a maximum temperature, for a cold object it is a minimum temperature. So the character of heat is flow from high temperature to lower temperature. So the heat flows, okay, like that. Okay, before that, for hot object it has some internal energy, okay, say U. And say for the cold object also it has a internal energy, say U. Once the heat flow from hot to cold object, this is the flowing of heat energy, okay. So the hot object is decreases its internal energy, it will be decreases. At the same time the cold object gets the internal energy from hot, so its energy will be increases, clear. So when the hot object is loses its heat energy, so that its internal energy will be decreases. Cold object is gains that heat energy, so that its internal energy will be increases, okay.